This is going to be a very quick scan through several different features we're working on. Lifeboat. Excuse me. I'm going to skip the intro of the Lifeboat just for time, straight on. See those if you're not familiar with Lifeboat. So, talked about this last time. At present, HDF5 is fundamentally an integrated library. We support thread safety through global mutex. The interesting thing to note here is the constraint imposed on all computers. We've been trying to do is release that constraint. So, true multi-thread support's been requested for a long time. Problem is, it's large, old, poorly documented code base, and retrofitting multi-thread support on daunting, very daunting. Thus, very little tangible progress to date beyond the global mutex. However, with ball layer, there's a fairly small number of packages which, if we can make those multi-thread safe, we can push the global mutex down far enough so that we can allow multiple threads to bulk of their support. And that's in essence what we've been trying to do. We're pursuing that strategy, retrofitting multi-thread support on the relevant packages, error indexing, property lists, context, and ball layer property. And we are developing a bypass layer both to allow faster I/O in limited cases and to serve as a test bed for the multi-thread improvements. So, at present, got working prototype for error and indexing. Those of you who were here last year know that I was thinking that indexing would go much faster than it did. Truth of the matter was, it wasn't so much coding the changes as writing the necessary test code. That has been quite painful. We have design work done or close to it on property lists and the ball layer proper with the context for a little bit because there are a bunch of dependencies in pretty much every direction. It's better to have a better feeling for what the other modules are going to look like. Moving on, lessons learned. When I was first asked to write this particular slide, my first 2 bullets was, it's worse than you think, and testing is much worse than you think. But that's not terribly useful. So I'll try and make some comments you might want to use if you ever do this sort of thing. Figure on multiple passes, not only on per module basis, but as you add additional modules. At least I've been finding interesting problems which have forced me to go back and review work already done. I think the best decision I made was to go lock free to the extent possible. That has helped tremendously on flexibility. In going through this, I've run through some internal and external APIs, which are really difficult from a multi-thread perspective. For the most part, I've been able to bypass them, then start negotiations on how we might change them. Some of them just have to be redone, support functionality, but the current API just doesn't work. And in other cases, I think some small semantic change community finds that acceptable. We'll be talking about that in the Thursday meetings as time goes on. Maintaining separation of concerns on these modules has been essential. There's a tendency for functionality to sort of drift in between modules a bit, and we have to push back on that problem so far successfully. And finally, there's the observation that the more complex the API, the harder the testing becomes. number of cases you have to try and reduce grows exponentially. A few things that have helped: collecting lots of statistics is tremendous, not only for spotting problems, but also for trying to figure out where the problems are. And for me, at least, lots of assertions, trying to throw assertions errors as close as possible to the point error occurred is helpful. So moving on to the bypass wall. As I already said, our objectives are to test bed and explore initial application. That diagram is what we hope the bypass wall will eventually become. We don't have the full multi-thread support available yet, so right now it only allows a single thread in. But the basic idea is to have a request come in, decide whether or not we can handle it multi-thread or not. We can, great, go off, query the native wall for the necessary location of what we need to read. And if not, let everything else drain out, then run that particular request down to the native wall. You'll notice in this diagram, we're doing I/O through what we hope will eventually be a multi-thread VFD layer. That's not available yet, so we're doing it all through P reads and P writes. So now this seems a little bit of a diversion, but this idea of querying the HDF5 library for location of raw data and then accessing it, ideally multi-thread, has been around for a while. We were able to do some work with the Blue Brain folks in Switzerland and help them not only tune HDF5, but also working with them demonstrated just how much we could get out of this particular strategy. The thing to note here is it's sort of a perfect case for this sort of thing, and there are lots and lots of very small data sets. So this shows you what we were able to do. Gray bar is HDF5 tuned as best we could do it. Then the blue bars are several flavors of querying the HDF5 library for locations of data, and then going with separate threads. I believe in this case it was 8 threads. So obviously we'd like to try and do as well with bypass wall. Still early days yet. Come on, you. Excuse me. But we have the bypass wall going to some extent. We've also set it up to use a thread pool to get some additional performance using even the single thread case. The benchmark we're using is a little bit different from the one that was used with Blue Brain. The data sets are larger, the chunks. So, anywho, we've done some testing. This is what we're getting. Linux, too much work in the way of tuning. For those concerned or thinking what I was thinking the first time I saw it, that particular Linux box only has 32 gig of memory. So I don't think we're running into cache effects. Over on Perlmutter, well, the results look very nice, but remember that we have half a tera of memory on each node. Moving to a larger data set, we're not doing this well, but it's early days yet. You'll notice there's lots of noise in these particular while we're doing one run per. Hopefully we'll be able to do better as things progress. Now, moving on to sparse data. I told you this was going to be frightening. As I'm sure all of you know, HDF5 does not have any support for sparse data. You can fake it in various ways if you want to, but it would be good to have native support. And thankfully, we are now in a position to do something about that. The problem has been known for quite a while. We looked at several different solutions, and what we finally hit on was say, okay, take your data set and break it into sections or chunks if you prefer. For each section or chunk, come up with a selection telling you which values in that particular section or chunk are defined, and combine that with the buffer containing that. We originally called this a sparse chunk, but the idea is actually very applicable to a number of different problems. So we've taken to calling it structured chunk, which is just a chunk with multiple sections. Each section. In this case, you'll see structured chunk for sparse data. The first section of the chunk is the encoding, or the selection of the data that we're storing, or has been defined in this chunk, and the second section is a buffer just containing the byte itself. You can extend this easily. Let's suppose we have sparse data with variable length. Well, just add another section, put a heap containing the variable length data, and augment the second section, the fixed length data, with offsets and lengths into the heap. You can use this for a lot of other things as well. So moving on. Status. We're on to phase 2, thankfully. Programming manuals and APIs are very on their way. Format extension. Changes we continue with the implementation. The structured chunk approach requires a lot of extra capability in the chunk cache. So we've taken this as an opportunity to redesign and re-implement chunk cache, trying to make it shared, and also thinking ahead, trying to design it in such a fashion that we'll be able to put multi-thread support in. And, as you can see, we're pretty convinced that we would like to turn support in. Let's see. Implementation of the APIs, command-wise tools is underway. I have an initial sketch design for the shared chunk cache. Big issue has been how do we fit this into the HDF5 library, allowing us to support the structured chunk without interfering with the existing dataset code. So design work on that is well underway. And it seems we will be having a prototype in spring of 25. Moving on. Actually making good time. Encryption HDF5. That's another long-standing quest we've had. Fortunately, we're now able to do something about it. The approach we're using is to use the EFD layer to convert all HDF5 IO into paged IO. Then once we've done that, we can encrypt and decrypt pages as we need. This allows random access to an encrypted file without ever decrypting it. And what's also interesting about this is we can apply the same idea in parallel if we leverage the existing subfiling infrastructure. So our current status, we're in phase 1. We have a serial-only proof of concept version, which is almost complete. It's going to be Linux only to begin with, running on the AES of 2Fish using gcrypt library. It'll be delivered as a pair of DFDs in HDF5 1.14.3. We are far from experts on encryption, so if anybody is interested in this, we are quite interested in reviews, comments. In particular, there's a question of how we should handle the API, how we should handle key distribution. Simply not my area of expertise. Looking for help on that one. Also, if this is something that you need, please consider writing a letter of support for us for phase 2. So when we get to phase 2, plans are pretty much what you'd expect. We need to finalize the API and key distribution questions, write production versions of the EFDs. That, of course, is going to include support for the key management and such. We also want to make the VFDs as encryption level agnostic as we possibly can be. As I said, we're really not doing encryption. We should make it as easy as possible for people to use it for encryption and frankly for other things as well. There's necessity to do odd things with the library. Going to be a need for all sorts of performance enhancements. Vector support will be thread pools in these. For parallel, we're probably multi-thread support and also maybe selection. And we need to make those VFDs fully plugged. That in turn means that we need to finish off and possibly extend the existing HDF5 pluggable VFD support. I suspect that key management is going to require some changes there. And this also is a good opportunity to finish out subfiling, because we'll need a number of things. We need to retrofit multi-thread support on the VFD layer. We need to update the subfiling VFD to support least vector I/O, and the I/O concentrators need to be modified to use the VFD layer. They don't do so right now because they can't get the necessary performance using only one thread. So as a result, they use, I think, typically 4 threads to do their I/O using 2 reads and 2 writes. So on the first 2 projects, the references there for documentation. I have gone over these things very, very quickly. I could easily understand anybody's eyes glazing over and wondering what the heck I'm talking about, but had to go fast. For encryption, I think documentation will be coming eventually, but let's see if we can get past phase 1. Want to thank DOE for supporting all of this, and thank you for listening. Questions and comments, please.
So you mentioned how difficult has been the testing of the book. We get, I understand. What are do you have any specifics on how you tested, or are you planning for using any formal benchmark to ensure that maybe my application to you, do you have any mechanisms that might allow to test that beforehand or before testing that you've done?
So, as I said, we're at prototype versions right now, so the emphasis is very much on correctness. Performance, of course, has to be there, but correctness first. The interesting thing about testing is, well, I've been using the standard Monte Carlo approach. But to do that, you can run lots of different operations and see if any of the asserts in your code trigger. And that's great. That'll get gross data structure corruption and sorts of things like that. Doesn't really tell you if you're correct. So to make things interesting, we wind up implementing a model, which is watching this stream of operations on your data structure, figuring out what the correct responses should be, checking to see if you're getting the correct response. And since we have some rather complex APIs, you'll occasionally run into a situation where you can't tell. So we're also counting the ambiguous results. The testing is extremely time consuming. I think the most recent version of tests for H5i was about a 10 or 11 hour runtime. I think Renee said it was about 24 hours on his laptop. So, yes.
I definitely think there's a space there for some like I know I run distributed systems, right? So and like I run at the same time. Why is the evaluation page 11 time? It's like I run a condition that I've never seen before. It's the same program. Just this time, process 1 executed faster than process 2.
When that happens, there is one known issue in the existing test set that I know about. It's incredibly uncommon, and it's a case that we may choose to avoid by doing shutdown with a single thread, or we may have to update the shutdown. So, yeah, very well known. I think the other thing that I found very useful is running the same test code not only repeatedly, but with varying numbers of threads. So I do with anything from 1 to 32 threads. Any other comments or questions?
Does it work for parallel HDF5 to export the setting for get what is like it is not what is I think
Having a hard time following.
will it work for for HDF5 parallel HDF5 multi-threading plus multiple threading?
So, it's a fair question. Simple answer is, I gotta get zero numbers. I haven't given much attention to it just yet.
Sparse data set, or do you allow for handling the positive? So if you have, it's a positive symmetrical matrix, do you have to actually write the symmetric part, or can you, in your proposal, just say, yeah, this is the same as this positive?
So you'll see this discussed in the API. The basic idea is you create a selection indicating the values which you find, and you write them. And everything else is done.
You have to write
You have to write and find everything. And there's also support for erasing data. Right.
I think Scott was trying to say, well, this half of the matrix is identical to that sparse half over there. I don't want to write this other because it's exactly the same as the other one.
So present optimization, frankly, haven't even begun much. So, anything else? Yeah. Well, thank you all.